Hello students. So today we want to discuss by what factor acceleration due to gravity changes when we go either down the earth or we go up the earth. It's very interesting to observe that the maximum value of acceleration due to gravity exists on the surface of the earth. So let's study. Now let's imagine a point mass m at a height h from the surface of the earth. So I can say that this is my earth and here is the point P having mass m at height h from the surface of the earth. This is the surface of earth. So obviously we can take radius of earth as capital R E. E stands for earth. Now what is the distance of point P from the center of earth? Obviously that is equal to RE plus H units. Now see, force f of h, force is a function of height, of magnitude f of h is equal to g into the point mass m into mass of earth divided by RE plus h whole square. Well, this is in line with the universal law of gravitation. So now we need to have little knowledge of binomial expansion. So that knowledge will help us to derive this expression. Now acceleration experienced by the point mass experienced by the point mass m would be, now this is as per Newton's second law of motion. Force is equal to mass into acceleration. Here acceleration is in terms of acceleration due to gravity. So it is mg. So I can say the acceleration experienced by the point at height h, that acceleration I would express in terms of g, which is also a function of h, is equal to force experienced by the point, which is also a function of height. That indirectly means the force experienced by the point mass is not same as we go up the earth, but as from a great distance we are coming towards the surface of the earth, divided by mass. So that is equal to f of h, we already know, is g, universal gravitational constant, and tau m cancels with m, it is me divided by R E plus H whole square. Alright, now we could always imagine a situation where this point is not far away from the surface. From this equation, it is very much obvious whenever x is equal to, let's say, in the denominator something is more, so the value of the x increases. So acceleration due to gravity would be less as Re plus H is greater than Re, which is there on the surface of the earth. So I can say as the denominator is more, acceleration experienced by the point mass at height h, g of h would be less than acceleration due to gravity on the surface. Or I can simply say, I can simply write g of surface is equal to g. Whenever I write g, it obviously means acceleration due to gravity at the surface, at the surface where h is equal to 0. Height of the point mass is 0. Now by what factor g decreases? We've already seen acceleration due to gravity is less. So as this h will keep on increasing, the point will go further and farther and farther from the surface of the earth. The acceleration due to gravity will keep on decreasing and decreasing. So can we have a relationship between g of h and g, so that we can quickly find out by what factor or by what percentage acceleration due to gravity has decreased as the point has gone above the surface of. In the equation number C. Yes, students, I can always name this equation as 1, which gives me the value of acceleration due to gravity with varying heights above the surface of Earth. So I can always rewrite this equation as, next page, g of h is equal to the universal gravitational constant into me, that is mass of Earth, divided by, see, it was Re plus h whole square, right? So I can always take Re square common. So it is GMA divided by, I take Re square common. So what I get is 1 plus h divided by Re whole square, right? Now this can be written as, this is equal to, now Ishma, what is this term? What is this term? G into me by Re square. Do you remember? What is G into me by Re square? You don't remember? Okay. So see that according to universal law of gravitation, force is equal to G product of masses m into m, mass of Earth, point mass, divided by Re square. So if I want to calculate the acceleration corresponding to this force, right? So I would say that acceleration g is equal to f by m. So it will be this whole thing divided by m. M will cancel with m. So g into ma by Re square is what, Ishma? This is actually g. So what is g? This is acceleration due to gravity at the what?
Surface of Earth.
Surface of the earth. So I can say g of h. This is acceleration due to gravity at height h. This is the earth surface. This is the point at height h. So g me by r is g, right? And 2, I can take this up, 1 plus h by re whole raised to power minus 2. Now guys, here I use binomial expression. So binomial expansion, hope you have a little bit knowledge about this. So there'll be a lot of terms, right? As we go up further and further, the terms will decrease, decrease, and decrease. So ultimately, their contribution would be less and less. So if we just concentrate on first term in binomial expansion, I can get little knowledge of binomial expansion. G of h would be equal to g into s minus 2 would come here. So 1 minus 2 will get multiplied by this thing, right? So it will be 1 minus 2h divided by r e. So this is, if I write g or g surface, it's same. So guys, this is a relationship between the acceleration due to gravity at height h and the acceleration due to gravity at the surface of the earth. Now since I've already proven that acceleration due to gravity is equal to gme divided by re plus h. Re plus h is more than re. That means the denominator is more, gh is less than g surface. If this is the case, then I think g of h, it's understood that it is decreasing. And if it is decreasing, by what factor it is decreasing? So we can say g of h at height h decreases by a factor of, yes, can you tell student? Can you tell Ishma? This is a factor by which it decreases. You have to multiply g by this, which is less than 1, to get the value for g of h. 1 minus 2h by re. You need to remember this to solve the questions. Alright guys. Now we consider the second case. What's the second case? Now we were going up and now we must go down. So let me draw Earth, which is obviously not a sphere, but let me assume for simplicity that it's a sphere. This is the surface of the Earth, students. This is the surface of Earth, right? So now I consider that my point has gone inside. The point mass has gone inside. Let's say it has gone inside at depth d. Now this is the center of the Earth. Obviously, the radius is re, and this small sphere, this sphere of the Earth, which is having the radius, this radius, students, is equal to this radius. This radius is equal to total is re minus d. So the mass of the sphere having radius re minus d is, this is smaller sphere. So I say this is mass of the sphere, smaller sphere, ms, whereas the mass of the Earth with radius re is me. So the point is going inside. Well, it has already been understood and proven in the previous lectures that there are circles or spheres around the Earth which have radius more than re minus d. There could be n number of spheres. I'm sorry, not spheres, shells. This is a shell. If you have a structure like this, we would not call it sphere, rather we will call this shell. So these shells will not exercise any force on the point P. This is my point P. This is my point P having mass M. So they will not exercise any force, all right? Yes, students. So now we're going inside. Now everything is clear. Radius of the portion of the Earth having mass ms is Re minus d, right? And forces because of outer shells is big zero. There's no force. You're not able to exercise any force these shells on point P. Okay, well, this is understood. So let's go further. There is a force this point P is definitely experiencing because of the mass of the Earth. The mass of the Earth or a kind of sphere having radius Re minus d. So how much is that? So now students, can we say that ms by me? How could we do that? So ms by md, mass density is equal to mass by volume. Mass is density times volume. So let's say the density of Earth everywhere is rho into its volume of mass. This portion of radius Re minus d could be taken as 4 by 3 pi r. The radius is Re minus d cube, which is exactly the radius of sphere. Rho density times volume is the mass divided by what is mass of Earth? Density time volume of Earth. So that is 4 by 3 pi. What is radius of Earth, Ishma?
Re.
Re. So it will be Re cube.
Cube.
Is this right? So this is equal
Yes,
to
sir.
Re minus d whole cube divided by Re cube. Very simple. All right. Having done this, we go further. So from this, I can say ms is what? Ms is equal to Re minus d whole cube divided by Re whole cube into Me. All right, I'm going to use this. Okay, so now, so from this, I also have an understanding that mass is proportional to uh, radius cube. I'm also having this understanding from these two terms. Okay, so what is the force on
So
point?
which
Yes, tell me.
so which radius are we talking about?
Sure. If we talk about Earth taken as a whole of mass me, then we will take Re as a radius. If we take the part of the Earth, the point has come inside after traveling distance d, right? Maybe in a mine. This point can be in a mine. So here the radius of the point is, as radius of the Earth of this complete sphere is Re minus d. So this is the radius, then the mass is ms. So whatever it is, whether you take complete radius of the Earth Re, or you take the radius of this much portion, encircled by this dotted lines, red dotted lines, then the mass is ms. Whatever is the case, ms mass is always proportional to radius cube. Can't you see from here? ms is proportional to Re minus d cube, because ms is the mass of smaller sphere encircled by this red lines. So this is proportional to Re minus d cube. If you say mass of Earth, well, this is corresponding to complete radius of Earth Re. This is proportional to Re cube. Hence I said mass is always proportional to Re cube. To understand further, take any distance. If you take any distance r and draw the sphere of the part of the Earth corresponding to this radius r, let's say the mass of this sphere is mq, let's say. So I can say mq is also proportional to rq. You got it? Any sphere inside the Earth. Let's go further.
Yes, sir.
Got it. That's good. Always Better ask questions. There's no question known as stupid questions. But when you understand, you start enjoying. See the video again, listen to it, write it, and then you understand better, go in depth. So mass is always proportional to radius q. So guys, you see that now. What is the force on point mass? Force on point mass m. So now the force is a function of d. What is d, Ishma? D,
Depth of
depth.
the
Depth. The point initially was at the surface. It has gone inside. I told you it could be a mine, maybe a gold mine or something. So there are mines which are dug kilometers and kilometers inside the Earth's crest, Earth's top surface, right? So this distance could be d. But now this force is a function of d. Force is a function of d. In the last lecture, we have also understood that g keeps decreasing as we come from the surface of Earth towards the center. Is it right? Do you remember that?
yes, sir.
Now, the mass m would be same. So as the g decreases, that means the mass m, which will have m into g as its weight here, the weight will also keep decreasing as it's go down towards the center of Earth. What does that mean? Well, that means the force is decreasing. Am I right? This is one way of looking at the things, that the weight of the weight of the mass m is decreasing as it's coming from surface of Earth towards the center. The other way of saying is, as the mass is coming down, the radius of the sphere which is attracting this mass, you see, the mass is not being influenced by all the shells outside. Okay, let's say the mass from the surface of the Earth has come to small sphere. It has come very close to center, right, Ishma? Now all these spheres, all these shells of the Earth, they are not able to exercise any kind of force on this point mass P, which is here. So the force exerted or experienced by this point mass is all because of the mass of the Earth corresponding to the sphere of radius. This radius could be r. So this force, as this radius is decreasing, is also decreasing, because the force according to universal law of gravitation is proportional to product of masses. As now this ms is shrinking, when the point was here, the entire mass of Earth concentrated at the center was attracting this mass m, right, Ishma? When the mass came here, so now it's only this much mass of Earth which is attracting the point, which is here. And then as the point is going down and down and down, the mass of the Earth is getting contracted. Which mass is getting contracted? The mass which is exercising a pull, exercising a gravitational force on this point mass m. So it's decreasing. That's why we say force is a function of d, is a function of depth. And you know, Ishma, when d becomes equal to re, that means the radius of the sphere which is going to exercise gravitational pull on the point mass becomes 0, because radius of that sphere is always re minus d. When d, because depth of the point becomes equal to re, that means the point is at the center. So what is the force becomes at that time? The force, gravitational force, becomes 0. This we have already seen in the last lecture also. Hope you have listened to it again. So let's go further. So what's happening now? Let's have analytical proof of this. Okay, one second. Okay. So force is a function of d, depth. As in the last case, as the point was going above the surface of Earth, force was a function of height. It means the force experienced by a point mass on the surface here is not same. It's changing. Rather, you could say now it's decreasing. We have seen it's decreasing. Why? Because g of h is decreasing, and we have already expressed g of h in terms of acceleration due to gravity on the surface. Similar is the case, Ishma. As we are going down, there's decrease in the force of attraction the point mass is experiencing. All right. So it's very interesting. This all sums up by saying that the value of g is maximum at the surface. Great. Fine. So f of d, I could write f of d as g into m. Yes, whether I will write m e or ms, because it is at a depth. It is not at the surface. Tell me.
MS.
Correct. So you are understanding. ms into m. ms is the mass of this much portion of Earth. This much portion of Earth, which I'm going to read again. Okay, good. So guys, this is g into m into the mass of point mass divided by what is the radius of this? I'm sorry, it's not m. It should be ms. What is the radius of ms? Radius of ms is re minus d whole square. Is it right, Ishma?
Yes, sir.
Oh, that's good. Now you put the value for ms. From here, what does it become? It becomes g into, so I put the whole value. Or maybe I can write this m first, and then the denominator re minus d whole square, and then I put the value for ms. So ms is re minus d whole cube divided by re cube into mass of Earth. So this is same re minus d, re minus d. So this I could always write that force the point mass is experiencing at depth d is equal to, I can write g into m e into r e minus d. If I make a mistake, please do tell me. Divided by r e cube. Is it right? So this is fine. I'll go to next page. So I got this, that f of d means force which is a function of depth is equal to, I'm just writing it again, g m m e into r e minus d divided by r e cube. Am I right? So now see that acceleration due to gravity mass is experiencing at depth d is force by, tell me, force divided by mass, because force is equal to acceleration due to gravity into mass. So this is F by right, students. So now we know acceleration due to gravity is a function of depth, and this is equal to g into me re minus d divided by this re cube. Re cube can be split into re square into ge. Now see this. This I can write this as g into ma divided by re square. This is preserved. This is g, as I have derived before, right? Am I right? This is g. Hope you understand. This is g into re minus d divided by re. Yes, is it clear now?
Yes, sir.
This thing This thing is acceleration due to gravity at the surface, g. Into, now you divide this, it becomes 1 minus d by re. Is it right? So now I got the expression, just like I got expression when a point mass is going up, height h. Now I got expression how a point mass is going down, the depth d. G is a function of d is equal to g on the surface into 1 minus d by re. So can you tell me, Ishma, how this expression is giving me a sense that g at depth d is less than g? Simply because, see, if you have 10 here and let's say you have 20 here, if 20 is being multiplied by a number less than 1, well, it's always understood 10 is less than 20. If 20, if let's say I don't know the number here, if 20 is being multiplied by some bigger number, then that means this number is more than this number. So 1 minus d by re. What is d? D is depth. It would be 1 kilometer, you see. So this is re is a very big number. Am I right? Am I right? Re is a very big number. Radius of Earth. Hello? Hello?
Yes, sir.
Re is a very big number. So this will be, this thing will be less than 1. Am I right? This thing will be always less than 1. Less than 1 means in order to make, g equal to gd, we need to multiply g with a smaller number. So that simply says acceleration due to gravity at depth d is less than acceleration due to gravity at the surface. This is clearly telling you. And by what factor it decreases? Acceleration due to gravity at depth d decreases by a factor of, can you tell me? 1 minus d by r. So your lecture is complete. We clearly know now how acceleration to gravity when the point is going up h decreases by what factor? Then g. When a point goes up, acceleration due to gravity decreases by what factor as compared to acceleration due to gravity on the surface when a point goes down. Thank you very much. If you like the video, do like it and share it with your friends. And in case anything is not understood, I'll be happy to answer it. Please do write something in the comments. Goodbye and good luck. Take care. See you later.